Welcome to the Micronaut podcast. I am your host, Sergio del Amo. I am here today with Iván López. How are you, Iván?
Hello, I'm very good, Sergio. Thank you.
Iván is close to me, so I was checking today the list of the top 10 committers in Micronaut, and we are 4 from Spain. So we are doing good, Iván.
That's awesome.
This is the first episode of the Micronaut podcast. It's going to be a short show that you can consume in your commute, that you can consume like every 2 weeks. We plan to publish it, and it will be between 15 minutes to half an hour. We are going to have several sections. The first section is going to be the agenda, that you stay up to date about what's coming and events. Then we are going to do a section called Level Up. The idea here is to highlight you a small class or something in the framework that you may not be aware of. Then we are going to be a main section where we catch up with a guest. So Iván is going to talk to us today about the GraalVM, what we are doing to test our GraalVM integration. And the last but not least is going to be, we are going to recap what we have published on the both in the Micronaut blog and in the Micronaut guides. So with all of that out of the way, let us get started. What's coming in the 18th of October, I'm going to be teaching a Micronaut deep dive training course, which is offered by the Micronaut Foundation. And that's, I will include a link in the show notes. That's going to be 4 days, 3 hours a day. So 12-hour total. And it's going to cover anything to get you started on the Micronaut framework. It's going to be a lot of live coding. If you are interested in getting up to speed to Micronaut, or you have members in your team and that you want to get started with Micronaut, please don't hesitate to register. Also, Micronaut project lead James Klee is gonna be doing a live talk in a live meetup. So now the meetups are coming live again. Hurrah! So that's good news. I will include a link in the show notes in case you are in James' vicinity. I think he's in the Ohio region, I believe.
Yeah, that's true.
And with that out of the way, let's go to Level Up. So one class that I want to highlight in this first episode is Yuri Builder, which is in the HTTP dependency. So if you are like using an application that you created with the default profile, basically will include Netty, and Netty has a transitive dependency to the Micronaut HTTP server and the HTTP component. So you're going to get this class, and you will use this class. For example, I use a lot because often you have to do like redirections in controller. You have like to go in this controller, you save a user, and you want to redirect to the user detail page. So that's really convenient because it's essentially a fluid API. So you call it like Yuri Builder off, and then you say contact, and then you can say .path, and then you pass the user ID, and it will take care of the URL encoding. So, and also it takes care of the slashes, because always when you are like concatenating paths, you never know if the variable that you have has like the trailing slash, or so it's really convenient class, really a small class. And if you are building Yuris, which probably you are, because who is not building Yuris, whether you are like redirecting or using the Micronaut HTTP client, this could be a handy class. For the main section, I am lucky to have Iván with me today. So Iván, when you create a Micronaut application, Micronaut is build agnostic. So you can either choose Gradle or Maven. And we have both a Gradle plugin and a Maven plugin. And they will allow you to generate GraalVM native images. And if you can give like a 10,000 feet overview of what a GraalVM native image is.
Sure. So basically, a GraalVM native image is a way, or is it's actually a way to convert our Java applications. We usually package our applications as a fat jar, so we run them with Java -jar. So with a native image, what we do is converting that fat jar into a native executable of your targeting operating system, which most of the time, especially for deploying to production, is usually Linux, right? Because we deploy on Kubernetes or things like that, so you don't deploy usually Windows or Mac OS applications directly to production. And the advantages of that native image is that it's a small binary and it doesn't have any dependency of the JVM. It's a binary like the one you can create with other languages like Go or C, C++. So it starts really, really fast, and the memory consumption is way low than the equivalent Java application.
The downside of GraalVM is that you cannot use typically reflections in your application, or at least you have to whitelist your reflection usages before generating the GraalVM native image, right?
Yeah, so what GraalVM does is, starting from your application entry point, which is the main class, during the generation of the native image, it basically analyzes all your code or your reachable code starting from your main point, and it kind of marks and target that those classes used to be included in the native image. So what happens is that if you are, as you said, if your application, or not your application, because applications usually don't do that, but frameworks and libraries use those techniques like, as you said, reflection, dynamic class loading, bytecode generation, things like that. A few of them are not compatible with GraalVM, and others works like the reflection, but you need to tell GraalVM, please, these classes are going to be used or accessed by reflection, so you need to include them. And the same happens with, for example, your resources. If you have anything on your source main resources directory, that needs to be included in your final binary, right? Because you put there your application config, your logback,
or static resources.
Exactly, or flyway migration, things like that. So you need to tell GraalVM, please also include those files in the final native binary. So you need to configure that ahead of time to be included.
Since Micronaut was released, and I think GraalVM timeline is close to Micronaut, we have seen a lot of attraction between both projects, because one of the things that Micronaut does is that we generate everything or a lot of things at build time, and the framework doesn't use reflection at all. So you essentially can use a framework such as Micronaut to use like dependency injection, validation, routing, all these things that typically will involve reflection. We do that without reflection. So in Micronaut and GraalVM were from the beginning a match made in heaven. And we have seen a lot of users using GraalVM native images of Micronaut applications from Micronaut 1.0, I think.
Yeah, that's true. So for those of you that don't remember, we released Micronaut 1.0 back in October 2018. So it's like now we are close to the 3rd anniversary. And yeah, by that time, and even before that, with milestones and release candidates, Micronaut worked with GraalVM. So yeah, as you said, Sergio, it's been working for 3 years, and we have improved a lot the user experience, because at the very beginning, creating a native image was really tricky. There was a lot of things that users need to do in their own applications. And since then, we have improved that a lot. And nowadays, it doesn't matter if you use Gradle or Maven. You just run Gradle W native image or Maven package native Docker or something like that, or native binary. I don't remember the exact command, but that's it. It's all that you need to do. Just do your regular application and run a Gradle task or a Maven target, and that's it. You will have a native image out of the box working for you.
We have like two options, right? So, for example, in GraalVM, so I have it, for example, here installed using SDK man, and if I basically download a Micronaut application, as you said, is that easy that we can explain it in a podcast. So I can like essentially like do like SDK list Java, by Java versions, select the latest version of the GraalVM JDK, switch to that, and then just run, I think it's Gradle native image, Gradle WB native image, and that will generate a native image of my application targeted for macOS, right?
Yeah.
And the other option is if I don't want to be running the GraalVM JDK, right, I can use like essentially generate the GraalVM native image inside a Docker image, right?
Mm-hmm.
And that's a common scenario that people will use to deploy.
Yeah, I think that most of the people will do that, because the first advantage is that it doesn't matter which OS you are running, right? As you said, you run Mac OS, but you don't want to deploy that to production.
Correct. I cannot.
Exactly. So building the native image inside Docker allows you to create the native image from your Mac OS. You don't need to even worry about having any dependency at all, because the only dependency is Docker. But you don't need to install, as you said, GraalVM with SDKman or any other option. And the final result of that will be a Docker image. So if you are already deploying your applications with Docker or with Kubernetes, that you just provide a Docker container or a Docker image, it doesn't change anything. It doesn't matter if inside that Docker image is now a native image, a binary, or it is a Java application that you run with Java -jar. It's just the same thing. You push a Docker image to your registry, and you deploy the same way as before.
I will come back to that because we have published a couple of guides which go along those lines. But we said that it's really easy to generate a GraalVM native images both with Maven and with Gradle, because we basically have done the heavy lifting and we have set up those build plugins to do that for you. You can still, if you are using a library which uses reflection, you can use our plugins are extensible so that you can provide basically provide that reflection configuration and generate the native image correctly. But the framework is that big. I was yesterday counting the number of modules that we have, and I think we have almost 40 modules already. So we integrate with many technologies. So we integrate with things such as Iván was saying before, so database migration tool like Flyway or Liquibase, or things such as Mongo or all the AWS libraries. So what we have done, and I think Iván can explain, is we are constantly testing that Micronaut plays when you are using Micronaut and one of these third-party technologies, we play well when you generate a native image of your application, right?
Yeah, that's true. So this started because very close to that 1.0 release of Micronaut. By that time, GraalVM was in release candidate phase. So basically what happened was that for GraalVM release candidate 5, it worked with Micronaut and everything was right. Then the team released GraalVM release candidate 6 and something was broken. So we needed to report that. They needed to fix it and wait for the next release candidate to be working. And that happened a few times, right? So what I did was we needed a better way to discover bugs instead of waiting for the final release. So this was back in January 2019. I created, I was thinking about how we could test this. So what I did was creating a very basic CI pipeline for testing, as Sergio said, GraalVM compiled from source code to be able to detect any regression or any issue before they release. So we were able to report bugs so they could fix it, and also we were able to discover bugs on our site and we were able to fix it. So I started using for that GitLab CI. By that time in January 2019, we were using for Micronaut Travis. So we moved to GitHub Action. I think was before 2.0, right, Sergio?
I think we moved between 1.0 and 2.0. I think probably in the middle of that year.
Yeah. So GitHub Action wasn't a thing by that time. And we couldn't use Travis because Travis had a lot of limits, especially for memory. One of the things that you need to keep in mind for building a native image is that you need a lot of memory. A typically Hello World basic application with Micronaut takes 6 to 8 gigabytes of RAM to build it. If you don't have that amount of memory, it will take forever because it's going to start swapping, or it basically will fail, saying an out-of-memory exception. So that was a hard constraint, and Travis wasn't allowed that. So I decided to use GitLab CI. I already knew it. For those of you not familiar with that, GitLab is like an open source competitor of GitHub. And GitLab CI is their CI. They had this GitLab CI for the last, 8 years or even more. So it's pretty mature, it's pretty solid. I knew well because I used that at my previous company. So what I did was creating a very basic pipeline, as I said. By that time it was, I think, every hour we check if there was some new commits in Micronaut master branch or GraalVM master branch. And if that happened, I cloned the repo, I built GraalVM from source code. Using that build, I constructed or built a Micronaut basic image of a basic application that I knew it worked. And then I started that application and ran some kind of functional tests, basically sending curl requests to different endpoints and checking the results. So that was our very basic pipeline back in January 2019.
GitLab, you can run so we use it on demand, but you can run it on premise. So in your previous company in Kaleidos, you were running your own instance of GitLab, right?
Yeah, we were running our own instance, and I was the kind of the sysadmin that took care of GitLab. That's why I knew it well, and I knew that it will work for us here. But here I'm using the open source, so basically the SaaS version they have. We don't have anything running on premises for this. Everything is public, so we don't need it.
We were lucky enough to have Iván on the team because, that experience with GitLab came really handy. How many functional tests are we running now? How many projects? Because Iván is constantly creating projects, they test a Micronaut feature with GraalVM, we'll create a project which verifies that a leaky-based migration works with GraalVM or Micronaut. How many of those do we have?
So at this moment, we grew up from one single application just tested with one version of GraalVM for JDK 8. And now we have 4 or 5 parallel jobs testing different things. So for example, we are very close to release Micronaut 1.0. So we need to test that Micronaut 1.0 master branch works with GraalVM stable release, with the pre-release because they are going to release one in a couple of weeks, and with master branch. So those are 3 different jobs. And we also need to test our previous version of Micronaut, which is 3.0. That also works with, in this case, the stable release of GraalVM. So at this moment, we have 4 parallel jobs. And for every job, we test with JDK. For the old versions, we test with JDK 8 and 11. And for the new version of GraalVM, we test with JDK 11 and 17. And for any of those, we have I think it's 40, 45, maybe 50 different applications. So we have, as you said, for Flyway, for Liquibase, a lot of microdata, JDBC. We tested with all different databases, H2, Oracle, MySQL, MariaDB, and Postgres. The same for JPA, also Microsoft SQL Server. We have for different our different views. We have this module in Micronaut views, which you can render server-side views. So we have for handlebars, find leaf, velocity, and I think there are a couple of more. And I think there are also for
MQTT, I'm seeing here in front of me.
MQTT, RabbitMQ, CAF.
For the security integration.
There are, as I said, something like 40. We can include in the show notes the links to the test applications and the pipeline. And they are also handy because sometimes when a user asks on our Twitter channel, I'm trying, Micronaut with RabbitMQ and the native image doesn't work. So what I always do is, we have this application that we know it works, so please take a look at that. Try to compare it with yourself. Maybe you are not using the right dependencies or things like that. And sometimes the user said, yeah, it works. It was something that we were missing, and that's it. So it's also like a way to document how this works for users.
It's also a way to keep Lex bugs coming to the system, which is always nice to think to do when you are maintaining an open source project. Iván is probably one of the top GraalVM issues reporter, I guess. They know you well in the GraalVM issues.
Yeah, I've reported a lot of them. because we have detected a lot of issues. Sometimes it's our problem. So with this CI pipeline, we also track and discover the issues on our side in Micronaut. But sometimes the issue is not on our side. So I've reported a lot of issues. And the nice thing about it is that we always have a test application, which is sometimes is the most complicated thing when you report an issue, right? This doesn't work. But yeah, this happened to us all the time when we receive bugs report from users. They said it doesn't work. We try with a simple application and it worked. So it's complicated. But for this case, I always have a test application that reproduces the problem. So I put an issue report explaining what happened with an application, and they know me and they know that I am Iván from the Micronaut team. We've working with them for a long time. And they fixed a lot of issues that I've reported, and they are pretty responsive with the community.
Yeah, we are in really close. So a bunch of the core development team of Micronaut is working in Oracle, and GraalVM is an Oracle Labs technology. So we are like in really close collaboration. So I think it's safe to say that if you want to generate a GraalVM native image, Micronaut is probably like the perfect fit for you. I just want to close this, Ivan. I think the recommendation that we will do for users is that if they want to deploy GraalVM native images to production, set up your CI pipeline, right? Because, as you said, generating a GraalVM native image takes time. Set up your CI, give it some memory to that particular job, because that will give you essentially faster GraalVM native image generations. And also bear in mind a lot functional tests, right? Because you have to test this. You have to do this black box testing when you're working with GraalVM, because basically you are not missing anything that works with native, but it doesn't work when you go and generate the GraalVM native image. Do you want to add anything else?
Yeah, no, just to what you said, it's important because the behavior is not the same. Something that works with the JVM, even if you are able to build a native image, it doesn't mean that it will work. Or something works, but then your execution path is other and it fails. So it's important to have those kind of tests. One of the things that I wanted to add is that now our Micronaut, Gradle, and Maven plugins we are in it's still a work in progress, or we are moving to use the official plugins, right? And one of the things that those plugins allows is to test your applications in this case with JUnit 5. So if you are already using that, there is a way now with the official plugins to build your native image and run all your tests, all your JUnit 5 tests with or against a native image. Our Micronaut Gradle plugin allows something like that, but it's not exactly the same. You can run different tests, but the behavior is not like that one. So this is a really nice approach if you want to start introducing GraalVM and you have those tests, because it allows you to run everything against that native image, which is really helpful.
Yeah, we can talk another day about testing if you want, but essentially just a 5-second overview is when you run when you have a test which it's annotated with that Micronaut test and nothing else, by default that will start your server, right? So the idea is that and you can inject an HTTP client pointing to that particular server. So the idea is that instead of starting a server and pointing your client against that server, what you're going to do is you're going to point your client against a native image execution, right? But yeah, we come back to testing because that's a topic that we are pretty fan of both. So we will come back to that another day. Let me go to thanking the sponsors. So this episode is brought to you thanks to the Micronaut Foundation, and especially thanks to the Micronaut Foundation sponsors. So Micronaut, when it was around Micronaut 2, there was the creation of a Micronaut Foundation. We'll talk more about the Micronaut Foundation, but essentially it's a foundation that governs Micronaut, and essentially it has a technical advisory board, which gives a high-level overview and recommendation about where the technology should go, and then it has a board of directors. And it basically is funded through sponsorships. And right now we have 2 sponsors, which is we have Object Computing, which is our ambassador sponsor, and then we have recently another sponsor called Safri.net, which is a bronze sponsor. And then we have a bunch of individuals which I'm not going to take the risk of trying to pronounce their names correctly in a podcast. So I will leave that for another episode. But thanks to everyone who is supporting the Micronaut Foundation. Thanks a lot to Safri. Welcome to the sponsorship. And thanks a lot to Object Computing, both for sponsoring the Micronaut Foundation and for paying my salary and Ivan's salary. So thanks a lot to both. And let us close the podcast with the guides and blog section. So this week, and this heavily is related to what we discussed with Ivan, is we published 2 guides which show how to publish a Micronaut application to Google Cloud Run, and we saw how to publish both a Docker image of your application and also a GraalVM Native Images. So Cloud Run, for those who don't know, is like a managed server platform that Google Cloud offers. And essentially, if you check out the guide, you will see that the process is really, really simple. And actually, if you want to work with GraalVM, Cloud Run, I think it's fair to say that it's a really good option. And essentially, you go basically, Google has I think it's called Google Container Registry or something like that, where essentially you can like push the Docker image of your the Docker image which will run your GraalVM native image, and then you just tell Google Cloud Run just run this image, and you will see that the startup time is blazing fast and really really easy to set up. For those new to Micronaut guides are I think it's fair to say less than 30 minutes step-by-step tutorials, which will guide you through one of the Micronaut concepts. And hope you enjoy the guides. I think we posted also the video of the 2GM town hall. 2GM stands for Groovy Glaze and Micronaut. So we do like a quarterly, like a kind of an informal community online gathering. And we had that meeting, it was last Friday or 2 Fridays ago. So make sure to check it out. With that, Ivan, we are close to the half an hour. Do you want to add anything?
No, I think that's it. Thank you very much for having me, and thank you everyone for listening. I hope you learned something new today.
Yeah, thank everyone for listening. Thanks, Ivan, for joining me today, and we see each other in 2 weeks. Thanks, everyone.